Have you ever paused to consider just how immense the universe truly is? Where does it begin? And more intriguingly, where does it end? These are timeless questions that have stirred the curiosity of philosophers, scientists, and everyday people for centuries. Despite our deepest inquiries and the advancements of modern science, we still lack a definitive answer. The scale of the cosmos is so staggering that it defies not only our measurements, but also our imagination. The distances between celestial bodies are so vast, the objects themselves so massive, that our brains struggle to grasp the full magnitude. Even with our most advanced tools and telescopes, we are only scratching the surface of understanding the universe's true expanse. Yet through the lens of modern astrophysics and the wonders of cutting-edge space observatories, we are beginning to glimpse the grandeur of what lies beyond our pale blue dot. Technological marvels like the James Webb Space Telescope have given humanity its clearest window yet into the depths of space. These instruments allow us to peer farther than ever before, capturing light from stars and galaxies that formed billions of years ago. They give us a sense, however minuscule, of the size and complexity of the universe, and with every image, every spectrum, every measurement, we're forced to reevaluate what we think we know. Recent discoveries have revealed structures of incomprehensible proportions, cosmic features so large they reshape our understanding of existence itself. One such recent revelation, identified by NASA scientists through the data from the James Webb Telescope, has been heralded as the largest known structure ever observed. It's a reminder that the cosmos is not just immense, it is infinite in ways that challenge our every notion of scale and perspective. To begin comprehending such enormity, we must start small, by cosmic standards. Consider our moon, which measures about 3,474 kilometers across. It may seem large when viewed in the night sky, yet it is only a fraction of the size of Earth, which has a diameter of approximately 12,842 kilometers. Earth, in turn, is overshadowed by Jupiter, the largest planet in our solar system. With a diameter of about 140,000 kilometers, Jupiter is a true gas giant, capable of fitting more than 1,300 Earths inside its volume. But Jupiter is not the end of the story. Beyond our solar system lies HD 10546b, a massive exoplanet, believed to be over 7 times the size of Jupiter, measuring nearly 1 million kilometers across. If Earth seems modest next to Jupiter, it is utterly dwarfed when compared to this distant world. Still, even these colossal planets pale in comparison to our Sun, which spans roughly 1.39 million kilometers in diameter. The Sun is so large that it could contain over 1 million Earths within its volume. Yet even this fiery giant is but a speck in the broader galactic landscape. One of the most massive stars known, Stephenson 218, is a red supergiant that reaches an estimated diameter of 9 billion kilometers, so enormous that it could engulf the orbit of Saturn if placed at the center of our solar system. Against such a backdrop, our Sun appears almost insignificant, but the cosmos holds objects of even greater magnitude. Consider black holes, particularly TON 618, one of the most massive black holes ever discovered. This titanic entity is thought to possess around 66 billion times the mass of our Sun, and is estimated to span about 390 billion kilometers. At this point, our measurements transcend planetary scales and even the scales of stars. We begin measuring. In light years, the distance light travels in a year, approximately 9.46 trillion kilometers. And with this unit of measurement, we enter a realm where distances become almost abstract. The Tarantula Nebula, for example, is the largest known nebula in the universe and stretches an astounding 1,260 light-years across. This massive cloud of gas and dust is a stellar nursery, a place where stars are born, and yet it is but a small feature in the larger fabric of space. Our Milky Way galaxy, which houses the Tarantula Nebula, spans roughly 105,700 light-years in diameter. It contains hundreds of billions of stars, trillions of planets, and an untold number of potential life-bearing worlds. And yet, the Milky Way is just one galaxy among many, so many, in fact, that they cannot be individually counted. The galaxy, known as IC 1101, is a colossus compared to our own, measuring around 6 million light-years across. It is one of the largest galaxies ever observed, and its scale makes the Milky Way look like a mere mote of dust. Even more mind-bending are the vast empty regions of space, such as the Bhuta's Void, a nearly galaxyless zone spanning around 1.8 billion light-years. The mere existence of such an expansive, barren region speaks to the mysterious and dynamic processes that shaped the universe's structure. But greater still is the Hercules Corona Borealis Great Wall, a massive galactic filament stretching over 10 billion light-years. To put that into context, this structure comprises nearly 11% of the observable universe. It is so large that it challenges fundamental assumptions about how the universe formed and evolved. Yet for all the awe these structures inspire, none are quite as philosophically provocative as the so-called cosmic web. This intricate network of galaxies, filaments, and voids resembles a massive neural structure, one that spans the entire known universe. Recent studies, including one conducted by scientists at the University of Bologna, have compared the architecture of the cosmic web to the human brain's neural network. Astonishingly, they found profound similarities in both appearance and structure. Neurons in the human brain and galactic clusters in the universe are both organized into filaments and nodes, with vast regions in between that seem largely inactive or empty. In both systems, only about 30% of matter or mass is concentrated in these active regions, neurons and galaxies, while the remaining 70% consists of more passive components, water in the case of the brain, and dark energy in the case of the universe. Despite the differences in scale, 7 orders of magnitude, the parallels in complexity and organization are uncanny. One of the researchers noted that the fluctuation patterns within the cerebellar neural network, from scales of micrometers to millimeters, mirror the fluctuations in matter distribution across billions of light-years in the cosmic web. This revelation prompts a stunning realization. Our universe and our own minds might be governed by similar physical principles, shaped by the same mathematical patterns. It's not that the brain is a miniature universe, or the universe a giant brain, but that both systems emerge from fundamental laws that encourage complexity, balance, and self-organization. This insight has far-reaching implications. The idea that everything is connected is no longer just a philosophical or spiritual sentiment. It's increasingly supported by scientific observation. Across time, cultures, and belief systems, people have intuited a deep sense of interconnectedness, the belief that our choices ripple outward, affecting not only our own lives, but also the world and people around us. In this view, the universe is not a cold, random place, but a unified system, a living network where every part influences the whole. This understanding invites us to live more consciously, recognizing that even our smallest actions play a role in shaping a shared reality. Whether from the standpoint of quantum physics, cosmology, systems theory, or spirituality, the principle remains the same. We are all part of a vast, intricate web. Our thoughts, behaviors, and intentions matter. They feed into a system that is continuously evolving, constantly responding to the stimuli it receives. When we say that everything is connected, we are expressing a truth that transcends metaphor. It is a reflection of the very fabric of existence. By embracing this truth, we are inspired to take responsibility for our role in the cosmos, to act with kindness, awareness, and purpose, to recognize that we are not alone and that we are, quite literally, made of stardust, connected by light, energy, and time to all that is. Thank you for exploring the cosmos with us today. If you found this journey as fascinating as we did, be sure to subscribe and support our continued quest to unravel the mysteries of the universe. Until next time, keep wondering, keep dreaming, and always look up.